Now let's take a look at your topic 3 worksheet 1 on covalent bonding. Okay. Now, first question. Now the electronic structure of atom P and Q are shown below. So you have two atoms over here, atom P, atom Q. Question continues. P and Q combine to form a covalent molecule. Okay, so you have to see a keyword over here. Please go and highlight it out. So it says that P and Q forms a covalent molecule, which means that they will share their valence electron. Okay, so with that, let's take a look at the atoms of P and Q and what will be the molecule that you will form. Now let's take a look at it now. So your atom P, right, normally usually in the center of your dot and cross diagram, right, usually this is represented by a P or a Q in the center, but in this case, right, the dotted circle actually represents the nucleus. Okay, normally we don't draw it this way, so just take note. So for P, right, I have a total of 1, 2, 3, 4. I have 4 valence electrons. All 4 valence electrons, they are unpaired. Okay, and on the atom of Q, I have 1 valence electron. So how would they share the electrons so that P and Q will achieve a stable electronic configuration of a noble gas? Okay, if you follow whatever that we have been doing normally, you will realize this should be fairly simple. Okay, so your Q, right, since it has only one valence electron that is not paired, you will share its one valence electron with one of the unpaired valence electron on atom P. And all you need to do is to repeat it for another 3 times. Okay, so first question asks you what's the chemical formula of the molecule form. So the answer should be PQ4. Okay, so basically you just need to pair your Q at the other 3 unpaired electron, valence electron of the atom of P. Okay, so you'll form PQ4. Next question asks you to draw a dot and cross diagram to show the bonding present in a molecule of P and Q. So now that you know that the chemical formula is PQ4, you should be able to draw it. Just take note, the size of atom Q is obviously smaller than the size of atom P. So you need to show that in your drawing. Okay, so I've already pre-drawn this in for you. So I do the usual way. Instead of the dotted circle, right, I have replaced it with Q as well as P in the center over here. Alright, so this is how they will share their electron. Take note, the key is actually already given to you over here, so you need to follow accordingly. So for P, right, we actually use the dot to represent the electrons of P. Okay? Next, let's move on to the next question. Now, question number 2. When atoms combine with other atoms, they can either gain, lose, or share a number of electrons. So the question continues. A carbon atom combines with sulfur atoms to form carbon disulfide, CS2. So you're asked to describe in terms of the number of electron gain, loss, or share. Okay. So keyword, you need to describe number of electron gain, loss, or share. How a carbon atom combines with sulfur atom to form carbon disulfide. So what are some of the things you need to do first before we even start answering the question? So first thing first, if you take a look at the question, right, question asks you whether or not electron is gained, lost, or shared. So we need to first determine for electron gain or loss, right? If it is gain or loss, we are looking at an ionic compound. Okay, so this involves transfer of electron. If it is shared, then we are looking at a covalent substance. So the first thing first, we need to determine, okay, for CS2, is this a covalent or is this an ionic compound? Okay, to do that, let's take a look at your carbon disulfide. All you need to do, actually take a look at the name. Then we determine, okay, for carbon, this is a non-metal. Sulfur, obviously, is a non-metal. So, between two non-metal, right, what I have will be a covalent bond that will be formed. Okay, so this is how I determine. And since this is a covalent substance, the electrons will be shared between the carbon as well as the sulfur atom. Okay, not gain or not lost. So I can eliminate this out. So how do we answer the question then? Now for each of the carbon atom, first of all, we'll write down the electronic configuration first. So for carbon, proton number 6, that means it has 6 electrons. Electronic configuration to 4. Each sulfur will be proton number 16. So 2, 8, 6. Okay. Now with this, right, you should be able to see or determine how, right, this actually shares the electron. Okay, and if you are not clear, all you need to do is to go and draw out the individual carbon atom as well as the sulfur atom first. Okay, so I'm just going to do a quick one. I will just draw, okay, so the valence electron shell. So for carbon, right, 1, 2, 3, 4. And for sulfur, valence electron shell, 1, 2, 3, 4, 5, and 6. Okay, so in the chemical formula is CS2, right? So basically I will have another 2 sulfur. So how would this share the electron? So same thing, you can see the unpaired electron. This will be how it will share the electron so that the electron will be paired. Okay, and if you draw another sulfur, I think you should be able to see what is going on here. Okay, how they will share the electron. So how will you answer the question then? Now, if you take a look at whatever that I have drawn over here, okay, you should be able to see that each of the sulfur atom, right, it will share its 2 valence electron with the carbon atom, okay, over here, 1, 2. Each of the carbon atom will share its 4 valence electron with 2 sulfur atoms. Alright, so if I were to draw this in, right, basically, if I were to draw another sulfur atom, 1, 2, 3, 4, 5, okay, 6. So you should share electrons over here. Okay, so each of the sulfur will form a double covalent bond with the carbon atom. So this is how your CS2 is formed. Now with this, once you are able to answer this, the dot and cross diagram shouldn't be a problem. Again, take note of the size of the atom. As you can see, right, for the carbon atom, it only has 2 electron shell, therefore the carbon atom should be smaller. Okay, so this is your carbon atom. Your sulfur atom should be bigger since it has a total number of 3 electron shells. Okay, with this, we can draw in the electron. So the total number of electrons shared between each carbon and each sulfur atom is 4. So I'll draw it in 1, 2, 3, 4. 1, 2, 3, and 4. Okay, and then for each of the sulfur atom, I will have 4 electrons that does not take part in the bonding. So 1, 2, 3, 4. Okay. Take a look at the question. Question only asks you to draw the outer shell electron, which is what I've done over here. So this is the answer. You do not have to show the first 2 electron shell, okay, for the sulfur. Remember to write your key. So dot electron of S, and then for your cross is electron of carbon. Alright, and we continue. Now, next question asks you to explain why carbon disulfide has a low boiling point. So, first of all, something very similar. Low boiling point is basically a physical property of your covalent substance, right? So, as previously we have already determined, this is a covalent compound. So, to answer this question, basically, this is a very straightforward question. All you need to tell me is that this is a covalent substance and it has a simple molecular structure. Therefore, small amount of energy is needed to overcome the weak intermolecular forces of attraction between the molecules and separate the atom. Sorry, separate the molecules, not atoms, sorry. So, few things you need to mention in this answer, like what I've mentioned to you, 4 things to be exact. 1, weak intermolecular forces to attraction, the molecules, and last but not least to separate the molecules. So make sure you have all 4 in your answer. Alright, we move on to the last question. You also suggest if your carbon disulfide is able to conduct electricity when molten, and ask to explain your answer. Again, first thing first, we need to understand that this is a covalent substance. Then you go and think back physical properties of covalent substances. Covalent substances, they do not conduct electricity in any state. So you answer that part of the question first. It will not conduct electricity when molten. Why? Okay, standard answer. Basically because it's a covalent substance and it has a simple molecular structure. Therefore, there's no free moving ions or electrons to conduct electricity. So that's all for this worksheet. Please do your corrections.